So what if the key to building better AI wasn't just about feeding it more data, but about giving it, well, smarter teachers? Today, we're going to dive into some really fascinating new research that does exactly that. It's a self-improving method designed to build smarter, safer, and more factual AI right from the ground up. I mean, it's a question we've all asked at some point, right? You're using one of these state-of-the-art AIs, and out of nowhere, it just gives you a completely fabricated fact or says something it really shouldn't. And you might think, that's a weird glitch, but the reason for it is actually much, much deeper than that. It's fundamental to how these systems learn.
So let's dig into what people call the AI's hallucination problem. But really, it's better to think of it as a flaw in the very foundation of how these models are built in the first place.
Yeah, these errors, these so-called hallucinations, they aren't just random quirks. They actually come from the core way most AI models are taught to think. And we're not talking about small-scale models here. We're talking about the most powerful, most expensive models in the world. They can still generate unsafe or just plain untrue content because these flaws are baked in from the very beginning of their training.
You know, the standard approach has been to try and patch these problems after the main training is done. But as this slide just perfectly illustrates, that's incredibly difficult. It's like trying to fix the foundation of a skyscraper after it's already been built. It's messy, it's hard, and a lot of the time, it just doesn't work.
So how do they actually learn then? Well, the traditional method is honestly surprisingly simple. You can basically think of it as a massive high-stakes guessing game.
It's called next token prediction. The model is fed trillions of words from the internet, from books, from articles, the whole shebang. And its only job is to get really, really good at predicting what the next word in a sentence will be. That's it, over and over and over again.
Think about it this way. Imagine a student who just memorizes the sequence of words in a history book. Yeah, they might be able to finish a sentence correctly if you start it for them, but do they actually understand the history? Nope, not at all. And that's the core limitation here. It creates models that are great at sounding plausible, but not necessarily at being truthful or safe.
And this is where the new research comes in and just flips the whole thing on its head. It proposes a completely different approach called self-improving pretraining that builds a way better foundation from the very start. So let's see how it works. Okay, now check this out. This is the new setup. Instead of just guessing the next word, the AI model we're training, let's call it our student AI, gets help. It gets help from two expert AI tutors who guide its learning process right from the get-go.
So who are these tutors? Well, they're two specialized, powerful AI models, and they have very distinct jobs. Think of one as a master editor and the other as a very strict grader.
So, the first tutor, the rewriter, is like that expert editor. It takes the raw text from the training data and just improves it in real time. It can fix errors, steer away from unsafe content, whatever is needed. Then you have the second tutor, the judge, who acts as the grader. It compares the student AI's answers to the rewriter's perfect version and gives it a score.
And here is the crucial point. It's a continuous feedback loop. The student tries, the rewriter shows it a better way, and the judge scores its effort. The student then uses that score, that reward, to learn and improve through a process called reinforcement learning. It's no longer just predicting the next word, it's actively learning what a good sequence of words is actually supposed to look like.
So, the big question, does it actually work? Well, the results are pretty staggering. Let's look at the numbers.
Okay, first up, overall quality. In head-to-head comparisons, when human reviewers had to pick between the output from a standard model and the self-improving one, they preferred the self-improving model a staggering 86.3% of the time. I mean, that is a massive leap in performance.
And what about making things up? The model showed a 36.2% relative improvement in factuality. In other words, it was significantly more grounded in reality and far less prone to those frustrating hallucinations we talked about earlier.
This chart here just brilliantly illustrates the impact on safety. The baseline model, trained the old way, scores about an 85 on safety evaluations. But the self-improving model, it hits 97.5. By building safety in from the foundation, the improvement is it's dramatic.
And this graph tells such a cool story. This line shows how often the judge picks the student AI's own answer as the best one. At the beginning of training, it's low, right? The student is relying on its tutors, but as it learns, it gets more and more confident until it's generating high-quality work on its own nearly 100% of the time. It is literally learning to think for itself.
So what's the big picture here? Why is this such a big deal for the future of AI?
Well, first, it fixes that broken foundation. Quality, safety, and factuality are no longer just patches you apply at the end. They're core parts of the learning process from day one. Second, it's just a smarter way to learn. You're using the expertise of an already powerful model to teach the next generation. And ultimately, this is a huge, huge step toward building AI that we can actually trust.
One of the authors frames it perfectly with this quote. The idea is that instead of just telling an AI what to learn through raw data, we should create systems that incentivize it to learn how to be better. It's all about creating smarter learning environments, not just bigger data dumps.
And that leaves us with a really powerful final thought. For years, the race has been all about building bigger and bigger models, but maybe the real breakthrough will come from focusing on how we teach them. What if the key to unlocking AI's true potential lies not in the student, but in the teacher?